Hi Hires, we are looking specifically now at temperature regulation in humans and how we do that using a negative feedback loop. Right, negative feedback, you have seen it in Nat 5. Again, you can go back and look at this if you need to, but your general pattern is still the same. Okay, so we start with our factor at its norm, its normal point, or its set point. And then we have something that happens. Could be something that increases, or it could be something that decreases the factor, but something happens to change that. Receptors kick in. So we need something to recognize there's been a change. The receptors then send messages to effectors. The effectors are parts of your body that actually make something happen. And they produce a corrective response, which if it's increased, decreases, and if it's decreased, increases, brings it back to the norm. Okay, so this whole concept is really, really important. It is called negative, because if you do an increase, you then do a decrease. If you do a decrease, you then do an increase. So you're doing the opposite of what's happened. It is the negative of what's happened. And feedback, because it is created by what's happened. In temperature regulation, thermal regulation in humans, we are looking at the hair erector muscles, sweat glands, skin arterioles, the muscles if it's cold, and also a couple of other things that can happen in terms of your general metabolic rate. The effectors are triggered by nerve signals, and they're coming from the receptor, which is the hypothalamus. You just need to know that. Looking a little bit closer at your skin. So this is a cross-section through your skin. We have the upper part of your skin, which is the epidermis, and then you've got the dermal layers, and then we have a fat layer which insulates underneath that, and then we've got various other bits. Just trying to draw this diagram. So we've got a hair, we have a muscle, tiny muscle, which is attached to the base of the hair. You have a sweat gland over here which will excrete sweat, and then it will come out here, and a sebaceous gland which also produces the oil that is around your hairs. Okay, so if it's cold, this muscle here will contract, which means that it will get shorter. So it will become smaller this way, which means that it will pull this hair. So it's no longer at this angle, it's now going straight up like that. And what that means is that it traps, because there will be lots of them, a layer of air in here. Tiny layer of air, but nevertheless it works. And if it's warm, it just relaxes so that it lies flat. Your sweat gland is the obvious one, I think. If it's hot, releases more sweat. Now that means it takes heat away as the water is evaporated off from the skin surface. If it's cold, it will cut down on it to prevent evaporation loss. And the fat layer is just insulation. So one of the other really, really important effectors are the skin arterioles. So they are blood vessels that are quite substantially smaller than an artery, but larger than a capillary. And what they have is muscle cells that are wrapped round them. So if this is the arteriole down here, then what we have is each of these little red things here. These are muscle cells, and they can contract. So when they squeeze, they can make this diameter in here smaller. And that's it. Okay, so as they squeeze, they're doing something called vasoconstriction. And if they relax, leaving it as open as they possibly can, it's vasodilation. So if you're cold, the arterioles will undergo vasoconstriction, so they will get narrower, and therefore less blood will go to the skin. So if we're looking down at this picture here, this is your artery coming up this way, but there's just less blood going up through here. And so all of this section here is losing less by radiation. You're maintaining more towards your core. On the other side, if you're warm, then they'll open up, and so you get a wider, much wider part of the arteriole here, so you get more blood flow coming closer to the surface of your skin, and that is going to lose more heat by radiation. At the same time also, if you sweat, if you produce sweat as well, and you have a layer of liquid now sitting on top of this, then not only will you increase it by radiation, you will also help to take some more heat away by evaporation as well. So temperature regulation in terms of negative feedback loop, this is quite a big one. Here we go. Here's your core temperature, 37 degrees. There's an increase in temperature. It could be anything that's caused that. It could be exercise, it could be external temperature increase. Our receptors, remember, are now in the hypothalamus. So hypothalamus detects that we have a change, and it has to send messages to the effectors. But we have quite a long list of effectors. So sweat glands, skin arterioles, the erector muscles for skin hairs, metabolics. Now that's a general thing, saying that we actually can change our overall metabolic rate to try and cut down that increase in temperature. And also we have the option of conscious responses. Okay, so all of these effectors then produce a corrective mechanism each. So the sweat glands increase sweating, increased evaporation. The arterioles mean you get increased heat loss from radiation. We've got no air, so being trapped next to the skin, so we've not got extra insulation layers. You stop producing excess heat just by metabolism. And conscious responses, like it's too cold, go inside in the shade, or, well, it's unlikely in Scotland as much, but you know, you could just say it's too hot, maybe take off the third jumper. Okay, it goes down to core temperature again, and that's you done the first half of the loop. Okay, on the other side of the loop, if we have a decrease, still your temperature receptors in the hypothalamus, and we have pretty much the same list. We've got the sweat glands, but this time they're going to shut down. We have the skin arterioles going for constriction this time. The erector muscles are going to contract to trap a layer of air this time. Our metabolics are also going to be kicked in just that little bit more to try and burn off some extra energy. Well, not burn off, but produce some. Skeletal muscles are involved now, that's shivering, and again, put on the jumper again. So sweat glands, because you've got decreased sweating, will help to prevent loss by evaporation, less radiation loss, insulating layer, excess heat, more excess heat generated just by friction, conscious responses to warm you up, brings you back. And you need to know the whole lot. That's it.